Okay guys, welcome back to Electronics with Ben. This time I'm going to be looking at the voting logic circuit extension activity. Now hopefully, if this all goes well, this will be a handy guide to you completing this task until I come back. So what we're going to look at doing is exactly the same thing we did last week. We are going to create some Boolean algebra based on this truth table. Then from that Boolean algebra we are going to create a circuit. Now, what we need to do is add another little section down here called Boolean algebra. So exactly the same as we've done before, we're going to analyze the truth table outputs, then write down the Boolean. However, what we only need to concentrate on are the expressions where the output, so in this case, like is our output, we'll label that as Q. We only need to do the Boolean expressions when we have a 1 on the output. Now, think back to last week. If it's a 0, it means it's a not. If it's a 1, you just write down the corresponding input. So for this one, the first logic level 1 at output Q is when you get a 0 at A, a 1 at B, and a 1 at C. So we put the not bar above the A, dot B, dot C. Don't need to worry about the next one down because the output's a 0. So the next one we're going to look at will be 1 at A, 0 at B, so it's not B, and then a 1 at C. Next one below that is A dot B dot C with a line above it, or C bar, and then the next one is A dot B dot C. In order to get our completed Boolean expression, the next stage we're going to do is just simply write all these out, because it's what we're saying is to get a 1 on the output of the circuit, it's going to be this one, or the next one, or the next one, or the next one after that. And we need to indicate that it's this expression or the next expression by using the correct symbol. Now, as we figured out last week, the correct symbol for OR, because it's electronics, it's complicated, is actually a plus sign. So our complete expression will be A bar dot B dot C plus A dot B bar dot C plus A dot B dot C bar plus ABC, or A dot B dot C. So now we can use that completed expression in order to determine our logic gate layout. Now you guys are going to do this on Multisim. However, as this is a quick guide, I'm just going to quickly sketch it out. Now what we said before is, when we did this last week, is we need to identify our little groups. So we've got this first bit, and we've got this one, that one, and this one. So essentially now we've got 4 groups. 1, 2, 3, 4. So we've got 4 sets of inputs. Well, 3 sets of inputs that are going to be kind of shared out into 4 sets of processors, which roughly equates to a logic gate. And then we've got the bits in between, which are the ORs. So we know we're going to need some AND gates because we've got our 4 sets of our AND gate processors or expressions. And then we've also got some bars across the top of these, which relates to our NOT gate. So we're going to have a NOT gate for each of our inputs. So I'm going to start off with these NOT gates and our inputs. So what I'm actually going to do is write our inputs at the top, A, B, C. Then we're going to draw our NOT gates underneath like this. And then from this we can start to look at where our inputs are going to go. You don't have to do it like this, you can have them going across. The good thing that I like doing about this way is you can actually take a standard A, for example, input from there, and then not A from underneath, so it gives you a little bit more kind of scope and options to personalize your circuit design. So what we're going to have now is our first AND gate. So as you can see, our first expression which we'll highlight in pink, is this one. Not A, B, C. It's got 3 inputs, so we're going to need a 3 input AND gate. So 1, 2, 3, AND gate shape going off to an output somewhere. So for this particular one, it's going to be not A. So our not A connection has to go through the not gate. So this will be not A. Then it's B and C. So for this one, I'm going to go up to B. So it's before the not gate. So it's not B. And then we've got C as well. I'll put a little squiggle on this one so we can cross-reference where we're getting our signals from. So that's the first one. Our next gate, again, 3 input, A, B, and C. Highlight this one in orange. It's going to be another 3 input AND gate, not drawn in highlighter. 1, 2, 3, AND gate shape. So for this one, it's A. Now, because we can link it around here, hopefully it will start looking quite neat, or as neat as I can get it. For this one, we've got not B. And like I said before, if you want to join a line, you go and connect it with a dot. If you want to jump over it, you've got to make this little kind of bridge shape jump. So that's our not B connection. And then our C connection, I'm going to be sneaky and take it off the top of here, save me drawing extra lines. Okay, so that is our orange one. So you can see now how the circuit's starting to take place. I'm going to repeat this process until we've got all of our logic gates and our combinations drawn out. The next one, we will highlight that in this kind of reddy colour. You're starting to get an idea of the process that's involved now. NAND gate shape. This one is A, B, not C. So let's take our A from over here. Our B can come from over here as well. And then our not C goes in there. That is our red one. Now our next gate is just simply A, B, C. No knots involved for this one. I'm not going to shade it in either because it's the only one left. What we should be able to do is take it from up again here, A, B, and then there should be a C floating around somewhere that's not connected to a NOT gate. So if we use it from the orange one's probably the quickest one. Take it from here, jump all over these, and go into there. Perfect. So now we have just got the OR gate to take care of. Now you could use a 4-input OR gate if you wanted, and you can find one on Multisim, which is just a big OR gate like that with 4 inputs. However, I want mine to look a little bit better than that. So what I'm going to try and do is do a combination of OR gates that feed into each other. Now what I mean by that is we're just going to use a standard 2-input OR gate. I just think it fits nicer on the page. Obviously it's entirely up to you guys which option you choose. So we'll have the top 2 gates feed into this OR gate, bottom 2 gates feed into this OR gate, and then our final 2 outputs will feed into another OR gate. Hopefully this will work fine and it will go out onto our logic probes. Now don't forget, when you build this on Multisim, you will need to put some switches into the top of your circuit. Hopefully you've saved the circuit from the previous week and you can just copy and paste your switch configuration from there. Best of luck. Hopefully when you get your circuit working, you should be able to test it by comparing it against the truth table. And if the light shines on the end, or the probe lights up at the end, when you've got a 1 on the output with the corresponding input configurations, you've got it right. Well done.